Is space quantized what the evidence shows? Have you ever stopped to wonder, what is space really? How can it create distance, separating stars, planets, and even atoms? How can it carry energy fields like gravity and light that stretch and fade as they spread? For centuries, people have asked, but direct experiments have given us very few answers. If space were truly just an empty, continuous void, how could it do so much with nothing at all? In this short video, we'll follow the clues that have been hiding in plain sight all along, and build a simple, logical case for why space might not be empty at all, but a hidden network quietly shaping the universe around us. Clue number 1, distance. Distance is a kind of size, a measurable property of space, but measurement only works if we can count something. Today, we count units like meters or inches to measure distance, but we already know those units aren't fundamental truths. They're inherited benchmarks, rough first attempts made long before we understood the deeper structure of reality. To make real sense of any unit, we have to assume it's built from smaller parts. And this isn't just about physics. It's true for every information system we've ever built. Numbers are made from groupings of elements. Written language is made from groupings of letters or strokes. But why do systems like math and language work so well? It's not just human ingenuity. It's because these systems evolved to match the rule set of the real world. They rely on combining discrete elements, because reality itself is organized that way. So if space creates distance, it must be made of elements too. Tiny, countable pieces that give distance its meaning. We don't yet know exactly what those elements are, but without them, we couldn't define size at all. And without size, space would have no structure. Clue number 2, 3 dimensions. If space is made of elements, or points, and the difference between those points defines distance, then the next question is, how much structure is needed to locate a point in space? The answer comes from information theory. To define a unique point, to distinguish it from every other point, we need 3 coordinates. We call these dimensions. We need 3 dimensions worth of information to encode the spatial feature we call position, and by extension, the property we call distance. So space must be organized in 3 dimensions, not just as a visual experience, but as a necessary structure where each element can be uniquely identified. In a 3D system, the simplest way to connect elements is this. Each node links to 6 others, one in each orthogonal direction. This creates a clean, minimal structure, just enough to define position, and from there, distance, area, volume, and so on. Without this 3D backbone, space couldn't tell one point from another. Clue number 3, spherical diffusion. We've seen that space must be made of elements, and those elements must form a 3D network. But now we ask, how does energy move through that structure? In the real world, energy spreads outward in all directions, evenly. We see it in gravity, we see it in heat, we see it in electromagnetic waves such as light and radio. Space doesn't favor any particular direction. Energy fades smoothly with distance, no matter which direction it travels from the source. That means space must support truly isotropic diffusion, the ability for energy to spread equally in every direction from a single point. A rigid 3D grid wouldn't allow that. It would bias certain paths and directions. So there must be something more. Temporary connections, or dynamic links, that allow energy to spread evenly throughout the network. That's how a quantized 3D structure can still behave like smooth, continuous space. Clue number 4, inert to light. What does light tell us about the structure of space? Interferometer experiments show that light travels at the same speed in every direction, with no drag, no distortion, and no measurable delay. Space doesn't slow light down, bend it, or push back in any way we can detect, at least over short distances. So what does that mean for the structure of space itself? It means that if space is made of elements, those elements must be arranged with statistical uniformity, and at such a small scale that light follows all paths equally, with no observable deviation. This clue sets a scale. If space is quantized, The spacing between elements must be far smaller than the wavelength of light, beyond our current ability to observe. So even though light moves as if space is empty, it's more likely that space is structured, just structured so evenly that energy can flow without disruption. That's how a quantized system can appear perfectly smooth, and how space can guide energy without ever getting in the way. Clue number 5, redshift. Our final clue comes from something familiar, redshift. As light travels across the cosmos, it stretches, shifting towards red. The usual story? Space is expanding, and it's stretching the light as it goes. But let's think this through. Is light quantized? Yes. According to quantum theory, starlight comes in fixed energy packets, and red light carries less energy than blue, consistently observed in both theory and experiment. So when a blue photon leaves a galaxy and arrives here as red, something happened. Where did that missing energy go? Could space be quietly taking energy from light, one small piece at a time? If that's true, redshift isn't just a sign of expansion. It's direct evidence that space interacts with light in quantized steps. From Darwin's Machines, 2024. In this video, we followed 5 clues, each revealing something important about the properties of space. Together, they point to one conclusion, that space is quantized, made of discrete elements connected in a hidden network. This model comes from my book, Darwin's Machines 2024, where I explore how information systems shape our understanding of physics, space, and time. If this idea resonates with you, I hope you'll support the work by liking, subscribing, or sharing it with others. And if you're curious to go deeper, you'll find more science and tech videos right here on this channel.